Hello, and welcome to your scientific notation video. I want to keep this pretty short because I know you've dealt with scientific notation before. One of the main things I want to focus on is how we actually deal with this on a graphing or scientific calculator. But I do like to start with a little bit of a validity of why scientific notation is useful and important. So when we actually want to write like a really, really big number, which is very frequently done in things like astronomy, when you want to talk about distances between the Earth and the Sun, it's much easier. You don't have to write 1, 2, 3 with a million zeros after it. This is actually going to also come into play when we talk about a certain number that talks about how many atoms are in a mole. Which is a chemistry unit. So atoms are really small, so there are lots of them. So it's a big number. So scientific notation is helpful in writing those large quantities. In chemistry, we also deal with very, very small quantities. And writing these kind of like long decimals where we have all these zeros and, dealing with figuring out sig figs becomes a lot easier if you show this in scientific notation. I once took a course at college where it was an astronomy course, and a woman was loudly complaining about how stupid and useless scientific notation is. So I do like to take a minute to remind you that, when you're talking about regular day-to-day numbers like 150, scientific notation is not useful. But when you're talking about extremely small or extremely large numbers, scientific notation is actually making things easier for us. Another thing I want to point out is the difference, remember, between having a negative or a positive exponent in scientific notation is what really reminds you, is this a very small number? Is it a decimal? Or is it a very large number? So that's something that I always when I look at a number in scientific notation, I quickly look at that exponent and assess if it's positive, I know I have a large quantity. If it's negative, I know I have a smaller quantity. And again, as I mentioned on the last slide, so I'm always paying attention to my exponent. The number in front is something we call the mantissa, and there's actually a rule that this has to be between 1 and 9. So, if you had 10.3, you would change it to 1.03 and move your exponent accordingly. So again, as I mentioned, I like to look at that exponent real quick and kind of get a concept for how big or small most of my numbers are as I'm kind of deciding what I think that quantity looks like to me. So please take a moment and write each of these in scientific notation. I do want to mention with number 3, you would typically, here in America, write this. When we actually write large numbers in science, we actually tend to avoid using a comma. Commas are used in some countries the same way we use decimals, so that becomes kind of confusing. So, if you want to continue to use a comma, I have no problem with that, but I do think it's important for you to see what that might look like with just that space there, since that's pretty common in things that are kind of trying to look a little bit more international in terms of science. So I'm going to pause the video for a moment, and then I'll pop these answers up for you. What's important is, in terms of sig figs, we keep exactly what we had given to us, so that's why in number 3, I did keep a whole lot of numbers there. Those are all significant figures. So what I'm really doing on each of these is really just counting the decimals here, and you have to move 1, 2, 3, 4, 5, 6, 7 times. Nice big number, nice positive integer, gives me a 7 there. In this one, I'm going 1, 2, 3, 4, 5, 6 to get my decimal right there. And because that's a decimal, that gives me a negative for my exponent. And a couple more for you to try right here, if you haven't done so already. Uh-oh, my number got detached. So these are written out in standard notation. Obviously, great examples of horrible times to use standard notation. So we're moving this decimal right here over 8 times. 1, 2, 3, 4, 5, 6, 7, 8. That's a number where it's very easy to maybe forget a 0 or something. So scientific notation is definitely something that we want to use. So on this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 moves of that decimal. Nice negative integer reminds me that this is a decimal. Now, punching these into your calculator correctly involves using what I call the weird little E key, which is right here on your graphing calculator. Sometimes this is given as an exponent button on some graphing calculator, or on some scientific calculators. Sometimes it's given also, you'll actually see an actual E button. On your graphing calculator, you likely have actually a comma above the 7, so you have to use a second function. There are 2 E's there. We really only need one of them, so you'll hit that double E and get 1 E. When we want to punch in 2.3 times 10 to the negative 5th, the way that we punch that into the calculator is 2.3, that little E button, negative 5. And you do have to make sure that you're using the negative and not the subtraction sign. And the E means to the calculator times 10 to the. I know there's like a 10 caret button. Sometimes this button functions the way that we want it to, sometimes it doesn't. I don't 100% know the difference, but I do know that the proper way to put this in and get the right answer every time is by using that E. If you use the E and times 10 to the, it's going to move the decimal another time. So it is important that these are actually punched in a pretty specific fashion. So to try this out, you're going to divide 2.5 times 10 to the negative 5 by 2.6 times 10 to the third. So what you're punching into your calculator is 2.5. Then you hit that second function, get that little E, that's what you'll see on your screen. Negative button. If you hit the subtraction button, you will get an error message. 5. You can put that in parentheses if you choose. It doesn't really necessarily need to be. Then you're going to hit the division button, divide that. 6.2. That E button again, and then just 3 this time. And when you hit enter, you should get something pretty close to 4.0 times 10 to the negative 9. What this is actually going to look like, however, what this is actually going to look like on your calculator is actually 4.032258, blah, 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 blah. And then at the end, you see this little E negative 9. That used to scare me when I was in math class if I saw that E, because I thought it meant I did something wrong. In this case, it means you did something right, because this E means times 10 to the. So that means times 10 to the negative 9. A little proof for you that this worked out correctly. If you go through the steps of actually just dividing these kind of out by hand, 2.5 divided by 6.2 gives you 0.4. You're dividing, so you're subtracting your 3 exponents, which gives you negative 8. And then in order to actually put that into scientific notation, so instead of 0.4 times 10 to the negative 8, we move that way, becomes 4.0 times 10 to the negative 9. So, that's just kind of the handwritten proof of how you would do this by hand to make sure you get the right thing on your calculator. If you get very good at plugging these into your calculator and properly using the E, you will not have to prove anything. So I'm going to have you pause the video for a moment, and I'll put the answers to each of these up. All right, so you got 7.6 times 10 to the negative 8. Again, that's going to read as E negative 8. For number 14, 5.5 times 10 to the negative 8. For 15, you probably wouldn't actually put this in scientific notation. If you would put 0.9, that would be acceptable on things that we're going to be doing in class. I just did want to show it in scientific notation. Same thing for number 16. It's really 66. And that's a case where it doesn't make sense to put things in a scientific notation unnecessarily. It would just be a little bit of extra work. If you're still struggling with using your calculator to solve these, what you really need to keep in mind is you're not using times 10 to the, you're not using the caret button. You need to go back and really follow these steps exactly. Be very cautious about what the negative button versus the minus and all that kind of stuff. You do need to be able to properly put these into your calculator. It's going to become important down the line.